In this video, we will be explaining exactly what antimatter is. First, consider normal matter. You have your protons, neutrons, and electrons. Well, imagine if each of those had an opposite, a particle with the same mass, but all other properties are reversed. This is antimatter, denoted by a bar above the particle symbol. It is identical to matter in every way, but all other properties such as magnetic charge, baryon, and lepton numbers are all inverted. A proton would have a charge of positive 1 and a baryon number of 1. Whereas an antiproton would have a charge and baryon number of negative 1. Every normal particle has an antiform. Protons have antiprotons, neutrons have antineutrons, and electrons have positrons.
So if there are all these antiparticles around, where are they? Well, nowhere, because when antimatter and normal matter touch, they annihilate each other, releasing gamma radiation in the form of photons. The exact energy expelled follows the equation E equals mc squared, with m being the combined mass of the antimatter and matter colliding, meaning that 1 gram of matter touching 1 gram of antimatter will release around 180 terajoules, which is double the energy released by the bomb dropped on Nagasaki in 1945. That is a lot of energy. If we could harness this enormous amount of energy, it would be incredibly useful. 1.5 odd grams of antimatter would be enough to get a ship to Mars and back again. Here's the problem. So far, we don't have anywhere near 1.5 grams of antimatter. The process of making antimatter requires huge amounts of energy and only creates a small amount. It's also incredibly difficult to contain the created antimatter.
To create antimatter, a process called pair production is used. This process consists of firing two photons at each other. If the photons have enough energy, when they collide, two particles will be created. One normal particle and one antiparticle. The amount of energy required again follows E equals mc squared. To create an electron and a positron, 1.02 megaelectron volts of energy is required. To make that 1.5 grams of matter from earlier, it would take 270 terajoules, and on top of that, the antiparticle will almost always collide with nearby matter and immediately be annihilated, but more on that later.
However, if pair production could be harnessed, it has uses outside of creating antimatter. Due to the fact that a normal particle is created as well, it is theoretically possible to create complex objects from pure energy, allowing us to replicate objects based on a design on a computer. However, to create this cup of tea, with a mass of 600 grams, it would take at least 108 petajoules to create. As on top of making the normal matter for the tea, an equal amount of antimatter would be created as well. On top of that, some mechanism would need to be in place to stop the antimatter just annihilating the normal matter.
Pair production is likely how the Big Bang caused the formation of the universe, with the energy release creating all matter. However, this leads to one of the big unsolved mysteries in physics. If pair production makes equal amounts of particles of anti and normal matter, why is there so much normal matter? The main theory relates to a process called baryogenesis, in which the amount of matter and antimatter created is unbalanced. However, we are now out of time. Do the Mario, swing your arms from side to side. Come on, it's time to go. Do the Mario, take one step. And then again, let's do the Mario all together now. You got it. It's the Mario. Do the Mario, take one step. Come on, come on, it's time to go. Do the Mario, and then again, let's do the Mario all together now. Just like that. Dun 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 dun. Dick.